Good morning friends, just today we'll just go through your NAND gate. Okay, so already we know that the expression y is equal to a into b whole bar. So in this NAND gate we'll just go through your CMOS, NMOS as well as your by CMOS structure. Okay, initially first we'll just go through your CMOS structure. Okay, so now the logic whatever is applied mean, so when it is been given in a complementary form, then only this logic can be applied. When that is a into b, if the bar is given, if the complementary form is there, then only this expression can be taken. Okay, initially what we'll do is we'll just draw the demarcation line. Okay, below that we'll just place the since here a into b, into means your multiplication form, so it should be in series. So what we have done is here we have just taken the two n transistors in series. Okay, just I represent the naming n1 and n2. Okay, so this will be my gate, drain and source. So this is gate, drain and source. Okay, gate, drain and source. So because always for NFET the source should be grounded. For that reason the source is being interchanged. Okay, so source is in and the output should be taken at the drain region. So this is the structure. So we have just placed the two NFETs in series. Okay, so whatever you have done, if it is in series, so obviously the in a PFET it should be in parallel. Okay, so we just draw the two PFETs. Two PFETs parallel. So there is just the connection. So you just know what you have done is, so you just place the two PFETs in parallel. So this is my gate region. So source should be connected with the VDD. So these two are the source and these two are the two drain regions. Okay, so this one will be my P1 and this will be by P2. Okay, next, as we know that for the PFET the source should be what? Connected with the VDD. Okay, so VDD over and the VSS is being over. Now what? The two gate regions should be shortened for given the input. So this is the my V in, that is A, and these two have been shortened and given that it as the B. Okay, A and B is the inputs. Next the connection is what? Your output at the two drain regions. Two drain regions. Okay, now so if you want to, will just cross check the how exactly the operation take place. Already people have studied about this one. See here, when A and B, okay, when both are 0 0, what will happen? Both the transistor PFET will be in a on state and both the NFET will be in a off state. Since both the transistors in on state, what the output will be? VDD will be connected to the output and the capacitor will be placed and it will be charged. So we will be getting the output as 1. Okay, next for 0 1, what will happen? For 0 1, so this P1 will be in a on state, P2 will be in a off state, N1 will be in a off state, but N2 will be in a on state. Since it is a series connection, there will be no connection between output as well as the ground, but here the voltage can form from the P1 towards the VDD. So once again the capacitor so charged, so we will get the output as 1. In the same fashion for A is equal to 1 and B is equal to 0, the same thing. So what it has been previously. Okay, next in that P2 will be on. Okay, next 1 1 state, what will happen? In 1 1 state both the transistors will be in a off state, so there will be no connection between the VDD as well as the output, but here both the N1 and N2 will be in a on state, so there will be a connection between the output as well as the ground. So the capacitor charge will be just discharged and the output will be getting it as 0. So this is the truth table of your NAND gate. Okay, now we'll just draw the schematic for the stick diagram for this schematic. Okay, so first the same thing, the demarcation line. Okay, now the initially first the two transistors should be drawn. Okay, whether it may be drawn for your NFET or PFET or a NFET. Okay, just for our reference we just take the PFET. So the gate regions are being placed horizontally. Just I will draw the two gate regions with the dotted lines. Okay, so this is the polysilicon. So this, whenever it crosses over the P diffusion, then it is known as your one transistor. in the same fashion, since it should be placed parallel, so I will just placing it one beside the other. Okay, so this one is my PFET. Okay, next in the same, next I will draw what? The NFET, polysilicon horizontal. Next is your this and okay, just what I have done is the two. So this represents P1, P2, N1 and N2. Okay, next remaining are the connections. Okay, so in the same fashion how it is being connected, the two gate regions P1 and N1 should be shortened. So just I shorten by using the polysilicon. Okay, with that is with the dotted lines. Okay, in this also the P2 as well as your N2. So inside that just drawing the freehand diagram. Okay, a little bit the lines are not been coming straight. Okay, see here. Next, the two source regions should be just joined. So just drawn by using the what? For the connection purpose I should be using what? The metal. Okay, so metal means it should be of a fill. Okay, so this one is the VDD. Okay, see the two drain regions also should be connected for the output part. So this is also the drain regions. Okay, next, see the source and drain are being shortened. Okay, so here just the two. So here I can place the contact. Okay, next the other source is being connected with the what? The metal. So I should take the metal and VSS is being connected. Okay, next what? The two drain regions should be shortened and taken the output. So just take the metal and just mention the output. Okay, so this one is the rough diagram of your stick diagram. Okay, so just the representation is what? Dash lines A and this is my dash lines B. Okay, so this one is the schematic representation. Horizontal means if the gate regions are being placed horizontal, then this is the thing. So how the stick diagram look like, but so since it has been drawn in a freehand, the lines have been not been coming in a straight. So exactly it should be of a same width for all metal, polysilicon as well as your N plus as well as your P plus diffusion. Okay, now we'll just go the same schematic vertical as well as the stick diagram vertical diagram. Okay, see here also the demarcation line will be there. So if I want to draw this one, so same demarcation line, above that PFT will be placed and below this the NFT will be placed. Okay, so just I draw the one PFET. Okay, next is another PFET. Okay, so below two NFETs. Okay, remaining all the connections. So this one is my P1, so this one is P2, so this one is my N1 and N2. Okay, so this one. Okay, next, so already we know that the two gate regions should be shortened and given the input. So just take a straight line. So this is the connection for your gate regions. Okay, so this will be my A and this will be my B. Okay, next, representations of what? The gate source and drain. Okay, so this is my gate region and gate means where the input will be given, that part is acting as a gate. Where the VDD and V supply means that part will be acting as your source region. Okay, and the output should be taken at the drain region. Okay, so this will be my source. These two are the two drain regions. Okay, next, so this is gate, so this is my source, this is the drain, and this will be my source and that will be the drain. Okay, since it is a series connection, it should be drain and source. Okay, next, remaining are the connections. Since it is two parallel, so two PFETs, source region should be connected and connected with the shortened and connected with the VDD, and the output two drain region should be just shortened. Okay, so here next, so one of the source region is being, see here, this schematic, if you want, this is source is being shortened to a VSS, so just connect the VSS, and drain and source should be shortened, drain and source should be shortened, so this one will be in a series. Now the connection output between two drain regions and one drain off of this one, so just I will take that. So this is the output, so this is the output. Okay, the in between the two drain regions as well as this drain, the output is being just taken. Okay, now we'll just go for your stick diagram. Okay, so here also the same thing. So here the gate should be what? Placed vertically. Okay, so this is the P plus diffusion. If the blank is there, then so here also 2 PFE or 1 PFET with so polysilicon as well as this one. So here also the same polysilicon with the dotted lines and the N plus diffusion. If there is nothing, then it is considered for your stick diagram as N plus or P plus. Okay, so same thing. So just 2 PFETs have been drawn and 2 NFETs are drawn. So it's just for our reference, we can take it as P1, P2, N1 and N2. Okay, next connections. The two gate regions should be shortened. Just shorten these two gate regions with the same polysilicon. Okay, with that is polysilicon means that is the dotted line. So A and B are being given. Okay, remaining are the connection. The two sources should be shortened by using what? The metal. Okay, just shorten these two by using the metal. Metal means it should be darkened, filled with the material, that is the dark material. Okay, so this is the VDD. Okay, now the two drain regions should also be shortened by using the metal. Two drain regions will be shortened with the metal. Okay. Okay, the two drain regions are being shortened here. Okay, two drain regions are being shortened here. Okay, next see the schematic. So the source is connected with the VSS. So we are just taken by using the metal and we have been connected. Okay, now for the output in between the two drain regions, it has been taken. Okay, drain and see in between the two drains, it has been connected by using the metal, and the drain of this beam, that is the N2 transistor, has been connected. And okay, one thing, so we just drawn the the freehand diagram has been drawn. Okay, so you should be drawing it neatly. Okay, as it's given in the text. Okay, next another important thing is the difference between the schematic and the stick diagram as well as the things. Okay, stick diagram represents by using a single the schematic is been represented by using a single line, but the stick diagram are been using by the double lines. Okay, as well as it is having all of the same width. Okay, width will be of a same. Okay, only the difference between the how the representation of whether it's a gate region N plus P plus or been metal are been using by the monochrome. Okay, if the material has been filled with the dash line, then it is known as your gate input. Okay, gate, that is it is acting as your input. P plus or N plus, if it is of a plain thing, then it is representing your drain and the source region, and the remaining for the connection purpose we just use the metal which is been filled by using the dark color, but the width will be of a same. But in the layers what will happen, we will be following the design rules. That is, for the polysilicon we will be having a 2 lambda, for N plus and P plus will be having a 4 lambda, but for the metal will be having of a 3 lambda. So these are of the standard form. Okay, so this one, the textbook how they have been represented, we'll just go through it. Okay, see here. So this one is of a 2 input NAND gate. Okay, so what we have drawn and what it is been is only the face of the first P transistor is being changed along with the N. Okay, the face we have just taken the mirror image. Okay, so this one is being placed by drawing the gate region horizontal. Okay, so this one is the stick diagram for that, this one. Okay, see here, but the gate region here being placed vertically. Okay, it is depend upon the author how they will be just drawn. So we have just referred both the thing in a previously, the schematic as well as your both horizontal as well as vertical. Okay, see here the two source regions have been connected with the VDD. So previously the same thing has been done. Okay, the two inputs we are representing the gate region. Okay, in between the two drain regions along with one drain region. The see here, the little bit of a connections is been changed here due to the author's representation, and is left to use. Okay, see here. So this represents the horizontal schematic. So this represents the horizontal stick diagram. Okay, it is same as your layout, only the thing is what, the width will be of a same thing. So here also the schematic is being placed vertically. Okay, so this one is the stick there. Okay, so try to draw it neatly by using your scale. Okay, since it is a freehand diagram, so just we have been drawn. Okay, so this one is the horizontal schematic of a 2 input NAND gate. So horizontal means because the gates are being placed horizontally. So this one is the schematic of a 2 input NAND gate. So this one is your horizontal layout. Okay, so this one is represented by a color chrome. Okay, so this one is exactly same as your stick diagram, only thing is it is been based on the lambda base rules. Okay, so the red color there is a polysilicon represents a gate region where the inputs are being given, and the metals are used for the connection where it has been for VDD as well as VSS along with the output, and the diffusions are being placed for this one. These two above part are been P plus diffusion, and these two are been acting as your N plus diffusion. This represents your vertical schematic of a 2 input NAND gate. Here the gate regions have been placed vertically. Okay, so this one is your vertical layout where the gates are been represented by your polysilicon vertically. Okay, so these are the metal connections, that is of a blue color, VDD as well as VSS as well as the output, and these are the P diffusion as well as your N diffusion. Okay, so wherever the polysilicon crosses over the diffusion part, that part is only acting as your transistor. So this one is your other form of representing the stick diagram. So this is also its okay. So this one is the schematic of a 2 input NAND gate. So 2 PFETs and 2 NFETs. Okay, so this one is a stick diagram. So where this will be represented, VDD as well as VSS should be represented by using the metal. 2 inputs by the gate region. Okay, B as we already discussed. Okay, and the output should be taken from the 2 drain regions of a PFET as well as 1 drain region from a NFET, and this will be represented by a output. Okay, the same thing. So instead of this lines, so we can just represent by another form also. Okay, that is see metal, instead of filled one we are just representing a straight line. So P plus N plus, so instead of this blank one we are just represented by a dashed lines, and the polysilicon, that is the gate region, instead of this dotted lines we are just represented with a separate dot lines. Okay, so this is the exact replication here wherever the metals are being used. So we are just taking the 2 straight lines. Okay, for the parallel connection, the gate regions is represented by the dotted lines. Okay, and the P plus is represented by the dashed lines. Okay, the 2 gate regions are being sorted by using the polysilicon. So see here, so just represented by connected by with the dotted line. Okay, and the B is also been represented, as well as the connection between this one is been represented by the output is been represented by the metal. So there is a connection of a metal as well as your N plus diffusion by using the metal. Okay, so in this fashion also you can just represent by using these things. Okay, it is left to you, so whichever you feel easy you can just go for it. Now this is the nMOS 2 input NAND gate. Okay, so in this nMOS means only we will just considering the input, giving the inputs to only the N input, since it is an AND gate. So A and B are being connected in series. Okay, and in nMOS there might be any number of inputs, but there will be only one PFET, and that too it will be just shortened, that is the gate region will be shortened towards the VOT, that is your drain region. Okay, so this one is the structure for your nMOS 2 input NAND gate. Okay, now we'll just go through the stick diagram. Okay, so A and B represents here the polysilicon, that is the gate region. Okay, see here the gate region of a PFT is shortened towards the drain region. So the two source regions are being shortened with for the VDD as well as the ground. And actually, so this is also, so the Vout whatever it has been represented, it should be of a filled with the dark color, that is for the connection purpose we require the metal. Okay, so this is also your metal, so this represents your V out, that is the, so this one is the operation of a nMOS 2 input NAND gate. Okay, so this is the other form of representing a nMOS stick diagram. Okay, so this one is your PFT, which has been shortened towards the drain region of a, so this one is a gate region which has been shortened here, the two inputs. Okay, here the dotted lines represents your gate region, the straight line represents your metal, as well as the dashed lines represents your N plus as well as your P plus region, as it is been mentioned previously. The metal should be placed with a straight line, P plus N plus with a dotted line, dashed lines, and polysilicon should be of a dotted line. Okay, so this is the other pattern of representing your stick diagram. Okay, now just will go through your NOR gate. The expression for the NOR gate is y is equal to a plus b whole bar. Okay, just for initially first you just going for your CMOS. So this one is the horizontal schematic. Since it is a plus b, so initially the first the demarcation line should be drawn, and the plus means so it should be in parallel. So first we are drawing the two NFTs in parallel. Okay, so N1 and N2, just for our representation we can just represent as N1 and N2, and this one as P1 and P2. Okay, next, so whatever the, since it is drawn in a N structure is drawn in a parallel, so exactly opposite should be for the P, means since they are drawn in series, so since it is drawn in parallel for NFT, so it should be drawn in series for the PFT. So this represents your gate, drain and source, gate, drain and source. Okay, and see the PFT of the first source should be connected to the VDD. Okay, the drain region of a second PFT should be taken as the output. Since it is parallel, the two source regions are connected to the VSS, and the output is been taken from the two drain region. So this one is the output. So this one is the stick diagram of whatever the means. The gate is being represented by the dotted line, dotted structure, and the NFT as well as the PFT are being with the blank space, and for the connection purpose along with the VDD and VSS we are just taking the metal. So VDD it is been metal, the VSS is been metal, and the connection, the two drain regions should be shortened here. So it should two drain regions to shorten, and it is being taken from connected with the drain region of a PFT, and the output is being taken. Okay, this is one way of drawing the stick diagram. So this one is the other form of drawing the stick diagram, how it will be represented. As already mentioned previously that the dotted lines are representing the gate region, the dashed lines are representing your PFT as well as your NFT, and the straight lines are representing VDD as well as VSS along with the connection. Okay, see here, all the three represent the same structure. So this one is been represented by using the horizontal schematic. Okay, next we'll just go for the CMOS vertical schematic. Okay, the same structure what it is being drawn for this, the same structure is being connected with particularly the gate region. Okay, see the two NFTs are in parallel and the two PFTs are in series. Okay, gate. So if you just remember the what are the terms, it has been represented gate, source and drain. So which are being connected or which are being shortened, the same regions are being shortened. See, two source regions are shortened and connected to a VSS. The two source regions are being shortened and given to a VSS. Here the two drain regions are being shortened and taken the output. Here also the same thing. Okay, in the same fashion, the one of the source region is being connected to the VDD. So here one of the source region is connected to a VDD, and the output is being taken from the drain region of a PFT and the drain region of a NFT. See here, the drain region of a NFT and drain region of a PFT. So this one is the conversion of schematic horizontal to vertical. Okay, so this one is the stick diagram representation of your CMOS NOR gate. Okay, see the VDD is been mentioned here with the metal, and the two source edges are being shortened and connected with this one. Okay, the thing is what it should be represented by A and B. So these are the two inputs, and the output has been taken from the two drain regions as well as one drain region of a PFET. So now we'll just go for your NOR gate in that nMOS. Okay, so already we know that in nMOS structure only will be concentrating on the nFET, and there will be, there might be any number of inputs, but there will be only one PFET, and the gate is also being shortened. So this one is the structure of your nMOS. Since here it is a 2 input NOR gate, so there are 2 inputs A and B for the N structure, and in a PF only one FET is there, and that to ground it is being shortened to a drain region. Okay, so this one is the stick diagram over this. Okay, see the two NFETs have been drawn. Okay, so it is same structure. So gate, drain, source and source. See the two gate is two sources are shortened and given to the VSS, two drain regions by using the metal. So that are bold. This one has been using as a metal. So and this one is used for the connection, and the output is being taken. So here the metal is being connected with the VDD, and the output is being considered with the metal output. So this one is the structure of your nMOS. This one. Okay. So now, so this is your. So later we'll just go through your BiCMOS structure. So now see this one is the structure of a CMOS NOR gate. Okay, so the what we have done previously is what we have just taken the mirror image of this PFET as well as nFET. Okay, so the connection. So this one is for nMOS, where the PFET is being shortened towards the drain region, that is the Vout, and the two inputs A and B. Okay, so here also now the same stick diagram how it has been. So it is been horizontally considered. So here we are just considering the vertical. So it has been explained already. Okay, so here also the same thing, and the input should be represented, that is the A and B. So these are the two structure of your CMOS as well as nMOS, two input NOR gate. Okay, the next section will just go through your BiCMOS structure of both NAND gate as well as NOR gate. So this is the schematic of a 2 input NOR gate. So this is the layout of the schematic, which is placed horizontally. So this is the vertical schematic of a 2 input NOR gate. So this is the schematic layout of a 2 input NOR gate, where the gates are being placed horizontally and the NFETs are being connected in parallel and the PFETs are being connected in series. So for PFET one connection is with VSS.